Okay, so in the last video, we learned how to use our charts to find out whether a substance will be solid, all right, whether it will stay as a solid and not dissolve, or whether it is aqueous and that substance will dissolve, okay? Now, let's talk about what happens when a substance dissolves, okay? So let's talk about the soluble ones, the ones that dissolve. These are the ones that are aqueous. So when an ionic compound dissolves, it does something that we call dissociation, all right? It dissociates. It means that the ions break apart. They separate into their individual ions. They leave each other, all right? The ionic bonds between the cations and anions are broken. During this process, the ions are surrounded by water, and this stabilizes them, all right? It makes them more stable, okay? And so let's talk about what a dissociation equation is. And you know what? I really am not a fan here. You can see we've got one here, and I'm going to just cover this up. I don't want to see this here because I'm going to write it on the screen here because it's going to be a lot easier to see. So I'm going to write it a little smaller. So let's talk about what dissociation is. So let's say I have NaCl, and we check on our chart, and we find that sodium chloride is aqueous. Again, all sodiums are aqueous, so this is going to dissolve. This is going to be aqueous. Okay? Now remember, the sodium and chloride is made up of positive sodium ions and negative sodium ions. I'm going to write it in here, and then I'm going to get rid of it. So it's made up of positive and negative sodium ions, and that comes from the charge, +1, -1. Now, we don't write that in when we have a formula, so I'm going to take them away, all right? But when an ionic compound dissociates, we write a dissociation reaction, which is like a little chemical reaction that writes the ions as their separate ions. Na +1, Cl -1, and we write aqueous, all right? And so if a substance dissolves, they break into their ions, and we write their charges back onto the ions just like we put them on when we were getting the formula. So these charges right here can come from the periodic table, right? From the periodic table where we find our charges, okay? And that's the way we determined our formula anyway. We determined them, remember, from the crossover. It's the same charges, all right? So we're just simply pulling them apart. So dissociation means to separate out or to move apart. It's kind of like you could use the word dissociate to say to your friend, maybe you had a friend for a long time and you decided you weren't their friend anymore. Maybe they sent you a text that offended you, and you might say, sorry, you're not my friend anymore. I am dissociating from you. I am not going to associate with you anymore. So you go one way and I go the other, and we will now be separate. So dissociate means to separate. All right? So in the ions, they separate. All right, let's take a look at some more examples. So, again, oops, I'm not going to use that. I'll write it down here. Magnesium bromide. Again, if we check our chart, all right, we can see that magnesium, and I'm using a different color here, magnesium bromide is aqueous. There it is there. So, magnesium bromide. In order to get the proper, the formula, I need my periodic table. I don't have one here, but you guys can look at yours. This is 2, this is 1, so I cross it over just like before, and I put the 2 right there, and it is aqueous. So how is it going to dissociate? Well, we're going to have 1 Mg plus 2 ion, aqueous. And notice here, we have 2 bromides. That 2 will become a coefficient to describe the fact that we have 2 bromide ions, and each bromide is a -1 charge. Okay, so that's a little different than the last one, because the last one was 1 and 1. We only had 1 sodium and 1 chloride. All right, there it is there. But because magnesium bromide has 2 bromides, we need to break it into 2 bromides. Okay, next, potassium, K, sulfate. We're checking the back of our table, SO4. Again, sulfate is -2, potassium is 1. We cross them over, 2, and I could put brackets 1, but we don't write it that way. So there's potassium sulfate. And potassium sulfate, again, if we check, and remember potassium is all aqueous, so I'm not even going to look any further, AQ, and now we'll break it into its ions. This time, there are 2 potassiums, which means I will have 2 K plus, aqueous. Notice we write the charge down again. You could write +1, and 1 sulfate, SO4. And if we check its charge again, it is aqueous. So there you can see we have 2 and 1. All right? Let's now look at the last one. Ammonium, NH4. Phosphate, PO4. Those are coming from the back of our chart again. Okay? Now, ammonium is +1. It's going to go down over there, right? Phosphate is -2. Sorry, it's a mistake. -3. That's going to go down over there, and we're going to need some brackets. So I'm going to have the 3 down there and the 1 down there, so I don't need to put brackets around phosphate. Okay, and again, if we check ammonium, like I said in the last video, all ammonium is aqueous. This is going to be aqueous. I might need some room here. I might have to write it down below, so I might need a little more room. So in this case, I have 3 ammonium, 3 NH4 plus, aqueous. I might squeeze it in, and I've got 1 PO4 -3 aqueous. All right? So again, when we have a subscript, all right, in our formula, it becomes the coefficient for that ion, because it's going to tell us how many ions there are. Okay, so one last example. What do we do if a substance doesn't dissolve? What if it isn't soluble? Well, then it doesn't dissociate. So if we take a look at our silver chloride, remember it's solid. Well, if it doesn't dissociate, it doesn't change. Nothing happens. It stays together. It's not exciting whatsoever. Okay? So again, let's take a look for the second one. Calcium. Calcium. Hydroxide. Hydroxide. And I know it's small, but hopefully you can see it. Little solid in there. So that's solid. So what happens to calcium hydroxide when we put it into the water? Does it dissociate? No. Calcium hydroxide solid stays the same. All right? So if it is solid, we don't change anything. It does nothing. All right. So there are some practice examples that you can work on, all right? And keep in mind, if it's solid, it does nothing. And if it's aqueous, all right, it breaks apart. into its ions. I want you to try these by yourself, and then I'm going to quickly do the solutions here in front of you. Okay? So pause the video and then try to do them, and then you can check in a moment. Okay? Okay, so you'll notice here in the homework it says a question sheet, and you will see on Google Classroom that you are to turn that in when you are done. All right? Excellent.